So already I have told you about the concept of variable, but the problem with the variable is we have a dependent and an independent variable. But the problem with the variable is that sometimes you cannot measure these variables directly. Let's say I want to conduct a study on whether monetary compensation, or let's say if I want to measure whether motivation leads to productivity or not. This is one study. Employee motivation leads to productivity or not. Now, employee motivation is something which I cannot measure directly. I can't ask a single question, are you feeling motivated or not? And on the basis of that, I can conclude my study. No, this cannot be done. Similarly, productivity cannot be measured directly. So sometimes when you have a variable which can't be measured directly, we break it down into constructs. Like the constructs of employee motivation could be punctuality. If an employee is motivated, he will be punctual. Working extra hours. Innovative. Oh, sorry, innovative will be the construct of productivity, right? Bringing innovativeness. Okay, working enthusiastically. All these are means motivation and this constructs of motivation and productivity. Again, to operationalize these constructs, I will make a questionnaire. But in most of the cases, what happens without identifying these constructs or without validating, even if we have identified, we are unable to validate that whether our questionnaire will measure all these or not. So let's say we have framed a question, a series of questions, but we don't know. And ideally, whenever we frame a question, most of the time we are not clear that which of these questions, hereby the questions I will refer to as items. So there are three levels: variable, measured by constructs, constructs measured by items. So we make items in our questionnaire, but we don't know which of these items are measuring which construct and which of these items are for our use, which are relevant for our study and which are irrelevant. So based on literature review, what we do, we create the items, but we are not sure that which of the items are measuring which construct, what is the name of that construct, and what is the interrelationship between those constructs. So simply we make a questionnaire. Also, we don't know that which of these items are of relevance to us. Same thing applies to the scientific studies. A effect could be caused by many reasons, but which of these reasons are of use to us? Let's say in clinical trials, when you give a medicine, it might produce a lot of effects, side effects, but which of these are relevant for your study, which you should take into account? We don't know. And what actually they are measuring, that also we don't know. Or let's say you have taken a standardized questionnaire used by someone in a study, and you are using in your study where your population is totally different. Let's say somebody has done a study in the US on consumer behavior. The same study you are doing in India on consumer behavior. Consumer behavior is affected by cultures, and India and US have different cultures. So even in that case, you need to know that the question that, because you need to do few changes in your questionnaire. So which of the items are measuring what and which of them are relevant to you, that always remains a question of the research. So for that matter, we perform a dimension reduction. So one of the dimension reduction technique is factor analysis. So I'll just share with you the screen. So when we have many items and don't know which set of items are measuring which constant or variable. Also, we don't know that which of the items are relevant for our study, then we perform dimension reduction. One of the dimension reduction technique is factor analysis. There are many types of factor analysis. Most commonly is the principal component analysis and exploratory factor analysis. Now, what common error I have seen people doing is, by default, when you do it in SPSS, it's reported as the method is principal component analysis. But we report it as exploratory factor analysis. Though both are dimension reduction techniques, but they differ in their way of how they do the dimension reduction. And both are used in different situations. And this situation is based on variance partition. Right? So, what does variance partition states? So, I'll put it here based on variance partition. Either you choose the component analysis or exploratory factor analysis. Now, what is this variance partition? See, when the total variance is explained only by a common variance, then we perform principal component analysis. When the total variance is explained by a common variance plus unique variance, then we call it as, then we apply the exploratory factor analysis. Here the assumption is that the components, because we are calling it as principal components, that the components are correlated with each other. They are dependent on each other. Here, the assumption is that components are not correlated with each other. So, if total variance is explained only by a common variance, H square, which is also known as communality, is equal to 1 or 100%. And here, communality is equal to h square minus 1. Sorry, not commonality, the total variance. Or, sorry, unique variance. Unique variance will be the commonality minus 1. So here there is no unique variance. Here there is a unique variance. Now, what is this unique variance and what is this common variance? See if all your items are measuring only one dimension or only one component. Here we will not call this component, we will call it a factor. If they are measuring only one variable or one factor or one dimension, then it is known as a common variance, means the total variance is explained by a common variance. And since components are the items that you are using are highly correlated with each other, so it's a natural thing that the total variance will be explained by the common variance, which is common among them. But sometimes what happens that the total variance is explained by the common variance of the items plus each of the item measures something extra apart from it. So the total variance becomes the sum of the common variance and the unique variance. So I'll tell you what is the structure actually in that case. Let's say structure is like this. Let's say you have 5 items. Item 1, item 2, item 3, item 4, item 5. Outcome. All these are measuring only the outcome and nothing else. This is the case of common variance because there will be commonality between them. And that commonality will come due to high correlation among these items. In that case, since items are highly correlated, plus the total variance is explained only by a common variance. Means all are only measuring the outcome, nothing else. Then this outcome will be measured only by these 5 items, and there will be common variance only. Now, second case is each item, apart from measuring the outcome, is also measuring something else. The structure is like this. What will happen? This outcome will become the sum of the common variance. Now, common variance will no more be 100% because here now, when we had common variance only, it was 100%, the square, the commonality. Now, commonality will be no more 100%. Commonality will be the sum of this common variance plus these unique variances. And outcome will be defined by the common variance shared by these items plus the unique variance of each individual item. In that case, we will perform exploratory factor analysis. Else, we will perform principal component analysis. So first we need to be very clear on whether we should go with principal component analysis or exploratory factor analysis. Because most of the time I have found people writing that they have done exploratory factor analysis, but the method written in the output is principal component because that's the default. So first you see whether your common variance, your total variance is explained by only the common variance or not. If it is explained by only common variance, then principal component analysis, and of course, there is a high correlation between the items. And if your total variance is explained by some portion of the common variance and remaining portion by the unique variance, means the outcome is the sum total of common variance and unique variance, then perform exploratory factor analysis. And in that case, since every item is unique also, they won't have much of high correlation among themselves. Okay. Is this concept clear? When to perform EFA and when to perform PCA?
Can you explain
I
unique
just
variance again? Sorry, please go ahead.
Sir, I will explain this with the help of an example.
Yes, sir.
So this is a questionnaire which is used to measure why people are anxious about using SPSS, right? Henceforth known as SPSS anxiety questionnaire. Okay. Now see, I have taken 23 items here, which these 23 items will be measuring SPSS anxiety. Now if you see the first item, statistics makes me cry. This is measuring people's anxiety about statistics. My friends will think I'm not stupid for not being able to cope with SPSS. This is measuring peer evaluation. Standard deviations excite me. This is measuring again statistics, anxiety. I dream that Pearson is attacking me with correlation coefficients. Again, anxiety of statistics. Fifth one, I don't understand statistics, anxiety of statistics. I have little experience of computers, fear of computers. All computers hate me, again, fear of computers. I have never been good at mathematics, fear of mathematics. So you can see if you take these 8 items, the they are measuring SPSS anxiety, that is common thing among them, but side by side they are also measuring anxiety about statistics, anxiety about mathematics, anxiety about peer evaluation, anxiety about computers. So this SPSS anxiety is explained by the common variance among them plus their unique variances that they are bringing in, like anxiety of statistics, anxiety of uh, mathematics, anxiety of computers. Okay, this is the case where the total variance SPSS anxiety is explained by the common variance plus unique variance of each of the item. Is this clear?
Yes, sir.
Okay. Now let's say I am removing these questions. Delete, delete, delete. Now consider these 4 questions. If you are trying to measure SPSS anxiety only on the basis of these 4 questions, they have a common variance only. That statistics, anxiety of statistics or fear of statistics is leading to SPSS anxiety. They are measuring nothing in themselves, only they are pointing towards SPSS anxiety. This is a common variance. Means the total variance is explained by the common variance. But when you are bringing in all these and see all these 8, if you see all these 8, then some are pointing towards statistics, some are pointing towards mathematics, some are pointing towards computers. So this SPSS anxiety is explained by the common variance among themselves plus their unique variances like mathematics, fear of computers, fear of uh, peer evaluation, like that. So that is the case of common variance. plus unique variance. So the total variance is explained by the common variance and unique variance. In that case, we will apply EFA. And there won't be correlation among these items, high correlation. Reason being, some are talking about statistics, some are talking about computers, some are measuring mathematics, fear, all. Okay. Suppose if we take only questions related to statistics throughout the questionnaire, and we are modeling that SPSS is leading to, sorry, the statistics fear is leading to SPSS anxiety, then the total variance will be explained only by the common variance. In that case, and there will be high correlation among the items because all are measuring the statistics fear only. In that case, the total variance is explained by a common variance, and we will apply principal component analysis. Am I clear on this?
Sir, is this like this unique and common variance is similar to like what is called as descriptive, no, sir, reflective, or this scale we call, one
See,
is reflective.
no. Reflective and formative scale is something different. When you try to find the interrelationship between the constructs, as of now, we are identifying the constructs. When you develop a scale based on those constructs, then we talk of formative skills and reflective skills.
Yes, sir, but sir, actually, when we like when I studied formative scale, then we studied that in formative scale, items are unique items.
Yes,
So
yes,
there
yes.
will be
All,
common plus unique
yes,
variance.
yes,
And
yes. But I'm not saying that you are wrong. What I'm saying, this stage will come at CFA.
okay.
Means the formative scale will be, in formative scale, the items will be independent of each other.
Yes,
And in reflective scale, the items will be dependent on each other.
yes, sir.
So situation is same. I am talking of the first step.
Okay, sir. Okay, sir.
So you are also correct. Means when you are developing a scale based on similar items, that is a formative scale. Okay.
Yes, sir.
When you are creating when you are creating a scale based on different items, which are having what we say, uh, common variance plus unique variance, then they are actually formative in nature.
Yes, sir.
Okay.
Yes,
So
it is now.
it's almost similar situation, but that is applied when you try to find the interrelationship of constructs. Here we are trying to find the interrelationships of items.
Items. Yes, sir.
Okay, that will be
Okay, sir.
applicable in confirmatory factor analysis.
Sure, sir.
Concept is same, the unique variance and the common variance.
Sure, sir.
Okay, the concept will be the same. So here, before deciding on principal component analysis or EF, exploratory factor analysis, we have to see that the total variance is explained by the only by the common variance or by the common variance and the unique variance. Right? Let's say, I'll answer your question also. Let's say I have found out 4 constructs out of this. Okay.
Yes, sir.
And all those 4 constructs are based on these 23 questions where items are independent of each other. Okay. Then that scale that I will develop will become a formative scale.
Yes,
Okay.
sir.
And when I will take questions which are common with each other, means, so it's very clear that for development of a formative scale, you need to do exploratory factor analysis. Okay. For formation of a reflective scale, you should proceed with, because first you have to identify those constructs based on similar questions. Since there is a common variance only that is explaining the total variance, then the scale that you will develop will be called as the reflective scale. Is that clear? I hope.
Yes, sir. Now got it.
Okay. So even at the step of, so means for developing the, if the scale is based on principal component analysis, it will be a reflective scale. If the scale is, sorry, yes, and if the scale is uh, based on exploratory factor analysis, then that is a formative scale. But that will be the stage after this. Okay. So when we will be having session on this, even we will cover this topic also. But as of now, because before doing confirmatory factor analysis, you have to do the factor analysis, isn't it? You have to identify the constructs.
Yes, sir.
Okay. But which method? The question is which method? Through principal component or exploratory factor analysis?
Yes, sir.
So this should be decided because if here you have chosen your method wrong, then in confirmatory factor analysis you will face a lot of problem. You won't be able to find the interrelationship of the constructs.
Yes, sir.
So
And
yes,
sir, for unique variance, you wrote h square minus 1, I think.
yes,
Sir,
commonality
what
minus
is that?
so sorry. This will be not h square minus 1, rather it will be 1 minus h square. See, here commonality means the common variance is equal to 1
Yes, sir.
because there is no unique variance.
Yes, sir.
But if there is a unique variance, then what will be the value of the unique variance? 1 minus h square,
Okay. Yes, sir.
isn't it?
Yes, sir.
See, commonality is equal to 1 means there is only common variance.
Okay, yeah, matlab that means unique plus common variance equal to 1. That will be the
Yeah,
maximum.
here we won't talk of the unique variance. No? Here there
Yes,
is no
yes.
unique variance. There is only
Exactly.
common variance. So h square will become 1.
1.
This
Yes,
is
sir.
known as commonality. And here unique variance will be 1 minus h square.
Okay, sir. Okay, got it.
Got it?
Yes, sir.
So when you will do factor extraction, you will get these values, and that will also tell whether you should proceed with the EFA or principal component. Okay.
Okay, sir.
If after extraction you find that commonality does not changes, that means there is only common variance. You should proceed with principal component. I'll show in SPSS. If you see that after factor extraction you get the commonality value changes, it reduces, that means the rest of them is the outcome of unique variance. Let's say initially it was 1, after a factor extraction you got a value of 0.75, so that means common variance is only 0.75. The remaining unique variance will be what? 1 minus 0.75, 0.25, isn't it?
Yes, sir.
Yes, sir.
Okay. So if you are finding that situation, then you can say that there is a common variance also, there is a unique variance also, which is explaining the total variance. So we will go with exploratory factor analysis. If common variance and unique variance, if commonality is equal to 1 and it does not changes, that means there is only common variance. Means we should proceed with principal component analysis. Okay.
Yes, sir.
And first initial observation, you can see if your questions are common, if their questions are highly correlated with each other. Like in my case, I have shown you the example. The questions are not correlated. You can see some are talking of statistics, some of mathematics, some of computers. Okay. If I remove all questions related to mathematics, computers, only keep the questions related to statistics, then I can say that only fear of statistics is leading to SPSS anxiety. That means there is a common variance only. But here we have different set of items which are measuring different dimensions. So apart from measuring commonality, because there is some commonality among them, that's why they are measuring SPSS anxiety. But apart from them, they are also measuring the fear of statistics, fear of mathematics. So we can say that the SPSS anxiety can be explained by the common variance plus the unique variance. And in that case, we will apply EFA. Is that clear?
Yes, sir.
Any confusion on this? Feel free to ask, because people often get confused on this part, the common variance and the unique variance. Should I proceed? Should I proceed ahead?
Yes, sir.
Okay. Now, once you have decided on which method to use, then the factor analysis, whether it's principal component or exploratory factor analysis, has two steps. Factor extraction. Here you will choose the method, principal component or exploratory factor analysis. Second, factor rotation. Factor extraction is very clear that you have to extract factors. Now, normally, we don't know how many factors to extract. Our questionnaire will converge to how many factors. So we do it on the basis of eigenvalues and scree plot. Scree plot is nothing but visualization of eigenvalues. Now, eigenvalues represent total of variance, amount of variance explained by a given principal component if you are doing PCA, or factor if you are doing factor EFA. There are few thumb rules. If eigenvalues are greater than 0, then it is a good fit. And if eigenvalue is negative, then it implies that the statistical model is a bad fit, because variance, eigenvalues explain variance. Variance cannot be negative. Third is eigenvalues close to 0 imply that there is atom multicollinearity. Collinearity I have already explained. There is the atom multicollinearity. Since, because if it is close to 0, that simply means that all your items will converge only on one component. So since all variance can be taken up by the first component. Perfect. So if EV or eigenvalue is close to 0, this means that there is an item multicollinearity, very high correlation between the items. So what will happen? All your items will converge only onto one factor. You will be able to extract only one factor, which is actually not required. Okay, we don't want to extract only one factor, because then what is the point in extracting? So always we go for eigenvalues greater than 0. Normally, if it is above 1, we keep the cutoff at eigenvalues above 1 in factor extraction, when we don't know that how many factors to extract. Second one is the factor rotation. Now, in extraction, what will happen? I'll show you one by one. What will happen that your items will load on all the factors. Suppose if you have extracted 3 factors, your item will every item will load on all the 3 factors, which will create a problem for you to interpret that which item should be loaded on which factor. Ideally, where it is loading higher, that should be taken into account, but again the table becomes very messy. So for better interpretability, we do the factor rotation. Now there are two kinds of factor rotation: orthogonal and oblique. Orthogonal rotation, this rotation is done when we assume that there is no correlation among the principal components or factors. So when we assume there is no correlation between the uh, principal components or the items or the factors, which method we use? Principal component analysis. And when we assume, EFA, and when you assume that the items are correlated, then which one method we use? Principal component. Here we are saying that we should choose orthogonal rotation when you assume that there is no correlation among the principal components or factors. Meaning, when you do EFA, you do the oblique rotation. Is this clear? Because in EFA also we assume that the fact that the items are not correlated. And here if we are saying that the extracted components or the factors are not correlated, then only we should go for orthogonal. That's clear, meaning that if you are doing EFA, do the orthogonal rotation. Is this clear?
Yes, sir.
And this rotation is done, second one is done when we assume that there is a high correlation among the principal components or factors. Meaning, when you do PCA, principal component, then choose oblique rotation. So, Varimax and Tomax are commonly used. Orthogonal rotation, direct oblimin, Equamax, and Quantimax are oblique rotations. So first, you should choose the factor extraction method based on whether the total variance is explained by the common variance or the unique variance. Means if the total variance is explained by the common variance, then principal component analysis for factor extraction and oblique rotation method. If total variance is explained by the common variance and the unique variance, then the method is exploratory factor analysis, and rotation method should be orthogonal, and you can choose any Varimax or Promax. Is that clear?
Yes, sir.
Okay. Now coming to assumptions of PF of factor analysis. AMO, sir, near, in, value should be greater than 0.5.
Sir, before you go ahead, I just want to confirm one thing.
Mhm.
Total variance, if it is explained by common variance, then it is PCA and oblique. Then if it is explained by unique plus common variance, then it is FA and then orthogonal rotation. Is this
Yes,
correct?
yes.
Thank you, sir. Thank you.
Because see, it's very simple thing. See, when we are saying that there is a common and unique variance, that means that the items are not correlated with each other, right? And orthogonal rotation is done when there is no correlation among the if there is no correlation in among the item, then there won't be any correlation among the extracted factors. So in case of EFA, you should apply orthogonal, because orthogonal assumes that there is no correlation among the extracted factors, right? When total variance is explained by a common variance, that only by common variance, that means there is a high correlation among items. If there is a high correlation among items, then there will be a high correlation among the extracted factors or components. In that case, you should do principal component analysis and oblique rotation.
Yes, sir.
Okay?
Got it, sir. Got it.
Okay. Then there, for doing factor analysis, one thing is sampling adequacy, tested by KMO, Kaiser, Meyer, Olkin. This value should be above 0.5. Second one is Bartlett test of sphericity. It should be significant. What does Bartlett significant means? P should be less than 0.05. So Bartlett's test of sphericity test that test a hypothesis that the correlation matrix is an identity matrix. So the null hypothesis that the correlation matrix is an identity matrix indicating that variables are unrelated. Now I'm talking of variables. Variables are unrelated and therefore unsuitable for structure detection. If this hypothesis stands true, then you cannot perform the factor analysis, any kind of. So for this hypothesis to be rejected, p-value should be less than 0.5. Means Bartlett's test of sphericity should be significant. These are only two requirements of factor analysis. Is this clear?
Yes, sir.
Okay.
If we can take one example and show in SPSS,
Sir,
will be
I'm
done.
going to show. First, I'm
Yes,
telling the
right.
theory.
Thank you, sir.
Using the same questionnaire which I have shared with you people, the
Yes, sir.
SPSS anxiety questionnaire, I'm going to show.
Yes.
But first, let me tell you what is rotation, what is
Done, sir.
extraction. Okay. So
Done, sir.
okay. So this is the factor extraction, factor rotation. Third stage is saving variables. You have methods of regression, the methods of Bartlett, and you have the method of Anderson rule. Now the thing is, see, if we take this question, okay, I'll come to this third one, saving, later on once we run this. Or let me explain, you have taken 23 questions. These 23 questions, you have taken responses on a scale of 5. Now, let's say 4 of the items are loading on one factor, 4 are loading on another factor, 5 are loading on third factor. But have you measured the score of first, second, and third factor? Because you have taken these individual questions. What will be the score of first factor? What will be the score of second factor? What will be the score of third factor? That you can do, because ultimately in the analysis you will be using those constructs, the relationship. What is their value? Because you haven't asked their values, you have asked the values of individual questions. So that can be created either by regression method, Bartlett method, or Anderson rule. So normally after EFA, we do CFA and structural equation modeling, which is covariance based SEM. So the best method that we choose is by regression method. We save the value of the variables. Now let's do one by one. So this is my questionnaire. Okay, one more thing I need to explain to you. I think I have already iterated on this, but sampling adequacy, from where it will come. See, your sample should be adequate enough. So ideally, we choose 1:5 ratio. That is, item is to sample. So for every individual item, minimum 5 responses you need to have. Okay. If you are doing non-probability sampling. If you are doing probability sampling and you have your population size is infinite, then you can use this formula of Cochrane for sample size estimation. And then you will be able to avoid the problem of this KMO. Okay. So this formula is N, which is the sample size, is equal to Z square, which is the standard score of Z at 0.05 significance level. This you can get from the Z table. It is 1.97 or something like that. P is the probability of the sample coming to be true, which is normally kept at 50%, so 0.5. Q is equal to 1 minus P, which is again 0.5, upon the error estimate 0.05. So if you calculate this, your sample size will come to 384. If you have taken 384 samples, 384 responses when you are doing a probability sampling, this is known as Cochrane's method of sample size estimation in case of infinite population. It will come to be 384. So minimum 384 samples will be required for avoiding the problem of KMO, or to get the KMO sampling, or to get the sampling adequacy, which is tested by KMO actually.
Sorry, sir. What is the name of this? Like as you said.
Cochrane's method.
Okay, sir. Thank you.
Okay.
So Shukla, why did you take E as 0.5?
What, sir?
You took E as 0.5.
Okay, sir. We took P as 0.5 because this is should be the probability, minimum probability of sample coming to be true, correct sample. Okay. You can put it at 0.7 also, sir, 0.8 also, based on your confidence.
Okay.
Then this value of Q will be 1 minus P. In any case, this value you will get the same, almost. Okay.
Okay, because PQ varies, so E also will vary.
Sir, sir, you are confident enough that the probability of my sample coming to be true is, means correct sample I have chosen is 70%. Then take 0.7, Q will become 0.3.
Okay.
However, ideally we keep it at that, because see, minimum confidence that we can put is 50% at least. So we take 50%, that is 0.5. Am I clear on this?
Yeah, you certainly. But there's
Yes, and sir, what will be the value of E here?
0.05, because 95% confidence you have taken, na 5%,
Okay.
which will translate to, this is the error estimate.
Yes, sir.
So if you put at this will be the Z score. If you see
Yes,
the
sir.
Z table, this will be the Z score at 0.05. Okay.
is 1.97. Yes.
It will be 1.97 approximately.
That's
Right? So if you square this, multiply with 0.5 into 0.5 upon 0.05, you will get approximately 384.
Okay, sir.
So in case of infinite sample, please keep in mind simply minimum sample size is 384. If you are doing probability sampling, okay, then your result will be generalizable. You won't get the problem of this KMO not coming to be true. All these things. It's not only applicable to the factor analysis. it is applicable to the entire study that this should be the minimum sample size. Okay?
But there are quite a few other methods to compute sample size.
Yes, sir. There are many methods. This is a proportionate method and this is widely accepted method. That's why I'm telling.
Okay.
And this is actually Cochrane's method and Yamane's method are widely accepted methods.
Okay.
Otherwise, there are a lot of there, sir. You'll find means you need not to do this statistics also, this calculation also. There are many online calculators available for sample size.
Oh.
But in that case, sir, you should know what is the size of your population.
Mm.
In case of infinite population, this is the best method, Cochrane.
Mm.
In case of finite population, another method by Cochrane has been given.
Okay.
This one,
Achha.
n is equal to n0 upon 1 plus n0 minus 1 upon n, where capital N is the population size.
Size actually. Okay.
This formula has been simplified by Yamane, and you can use this formula when your population, when you know your population size, finite population. N is equal to n by 1 plus n into E square.
Mm.
What is that symbol? Right?
Yes.
Where capital N is again your population size. When you don't know your population size and E is the error estimate, then you can use this Cochrane's method of, this is a widely used method. Okay. When you are doing probability sampling.
Correct.
When you are doing non-probability sampling, because you don't have a sample frame, you cannot randomize, then at least you should choose this method. This is known as KMO method, Kessler-Meyer-Olke method. Also, you can cite Uma Sekran and Bogi 2016. Even they have iterated on this method. Okay, that one point. And as per Nunalli also in 1971, he has wrote an article that in case of non-probability sampling, you should take minimum 1:5 item is to sample ratio. If after this also your KMO is not coming correct, please increase this ratio to 1:6, 1:7. Most of the statisticians, they say that ideally it should be 1:10. But if you can achieve it as 1:5, then why take the pain of taking a very large sample? Right?
Yeah, in fact, at very large sample, there will not be any difference in the results, the outcomes that be of the statistical analysis. That is another thought, isn't
So
it?
if increasing the sample won't have, so increasing the sample doesn't affect your outcome results. Actually.
Yes, that's right. That's what I meant. Yes.
But what it only affects is your effect size. Okay. Interpretation values will little bit change, but what affects your result is the kind of responses you are getting rather than the number of. Quality matters rather than quantity. But yes, minimum quantity has to be reached, means either 384 through Cochrane's method, or if you have a fixed population, then through Yamane method, or if you don't know your population going for non-probability sampling, then 1:5. Okay?
Yeah, that's
If you can achieve KMO at this level, fair enough. If not, then try to increase this number. Okay?
That's right.
So for one question, 5 items. So let's say if you have 20 questions, you can go for 100 responses. Okay?
Okay.
Excuse me, sir.
Yes.
Sir, when will we apply this ratio, like in case of infinite or in case of finite?
No, when you are doing non-probability sampling.
Okay.
Yes, you don't know about your population at all.
Okay.
Let's say you want to do one study where you want to know people's perception about circular economy, the green behavior, right?
Yes.
You don't know who are the people who are using this green products. So you will go into a shop, people will come there, you will ask them a qualifier question that whether are you a green consumer or not. If they say no, then you will remove them. If they say yes, you will hand over your questionnaire. But these are the people whom you have not predefined, you have not identified prior, okay, then this is a case of non-probability sampling. Then minimum sample size should be in the ratio of 1:5. So if you have 20 questions, at least reach out to 100 people with
Okay,
green
sir.
behavior who are exhibiting green consumerism.
Or it should also be, I guess, you would kindly confirm, if it is judgmental, let's say, a certain context require that only certain type of respondent should be there. Of course, you define the characteristic of the
Yes, sir.
respondent.
Even in judgmental, sir, judgmental is also kind of non-probability sampling.
That's what I said, yes.
So,
So
yeah,
again,
any
1:5.
any kind of non-probability sampling you are using, then since you don't know the population, you don't know the characteristic of the population, whether you are doing sampling by references, that is snowball, or
Mm,
judgmental, or
mm,
quota sampling, or
mm.
you are doing this
Clusters.
cluster is a probability
Oh,
sampling.
sorry, I'm
Okay,
sorry. Yes, that's right.
convenience sampling or
Yes,
proximity sampling. Okay,
yes,
then
yes.
you have to use this one method. Otherwise, use Cochrane's or Yamney's method.
Right. And if 1:5 doesn't really comes true on your KMO, then you increase change the 1:, that ratio
1 is
1:5,
to 6, 1 is to 7, 1 is to 8.
1:10. Yes. Yeah,
Yeah,
yes.
keep on increasing. Yeah,
That's right. That's
means
right.
keep on increasing your responses.
That's right. Okay.
See, large sample size have one more effect also. If
Mhm.
your data is not normally distributed, sometimes increasing the sample size
Yes,
does
can
you
lead to
does you the favor.
yeah, leads to normality.
Yeah,
Right.
sometimes it's not
Okay.
always.
Okay.
Depending on which kind of scale you are using. If you are
Okay.
using an ordinal scale, your data will never be normally distributed, irrespective of whatever sample size you take.
But Likert it does.
Yeah,
In
so
Likert it
Likert,
will.
so Likert in the basic Likert is an ordinal scale.
Okay.
If you take Likert scale in its pure form, it is
Mhm.
an ordinary ranked scale.
Mhm.
So normally those people who are using Likert scale might not be getting
Mhm.
the uh, this normal data. So what we do in Likert scale is treated as summated scale. So either you summate the scores, let's say question number 1, 2, 3, 4, 5,
Okay.
it is measuring something. Okay.
Yeah.
Don't measure the normality of question 1, 2, 3, 4, 5.
Mm.
Summate this score, make it, because the moment you summate this score, what
Mm.
you are doing, you are converting it into a continuous measurement. It will become a summated score, no? It will become
Mm.
an absolute value,
Yes.
and then you check its normality.
Okay.
Okay, because Likert scale is treated like that. It is
Okay.
known as summated score scale.
Okay.
Other thing you can do, if you are doing EFA, then you can save those values as regression, and then you check the normality of those created, because it will save the values of all the questions loading on a particular construct, and
Yes.
and then ultimately you will be using that construct to measure the relationship. So why to measure the normality of each individual question, because ultimately constructs will be used in the analysis. So
Yeah.
take, and these will be absolute values, it will come to be normal.
Right.
So never ever
Okay.
go for individual questions, Likert questions for
Mm.
measuring normality. That
Mm.
won't lead you to anything.
That's right. Okay.
And if your data is not normally distributed, sorry, I'm just taking, I'm
Please.
deviating from the topic,
Please.
but,
Please.
that's required.
Mhm.
So if your data is not normally distributed, then take its logarithmic value.
Okay. Mhm.
Even after that, if it is not there, then bootstrap the model.
Okay. Mhm.
I'll show you where are these options.
Okay. Yeah.
Trans- you go to transform compute variable, right?
Mhm. Okay.
Let's say this one, I want to convert it into logarithmic value.
Okay. Oh, well, that's interesting.
This gives you to submit the scores. Even if you want to submit the scores, you can take this sum here, and
Mhm.
you can put the value. Let's say I want to submit the score of 5 questions. So I need not to do it manually for each and every individual. Simply, I will take sum. I will put these questions over here, separated by commas. Okay. Let me do it for you. Separated by commas. And let me put the name of the variable sum underscore q1 to q5. Okay.
Yes.
Just plain legal character q1 underscore q5. Okay. So this variable have been created containing the summated score of all the 5.
Right.
Clear?
Yes.
This you can do. This you can do.
Mm.
I'm deleting it as of now,
Yeah.
so that we don't have any problem in our.
Right. And this would be a case, again, I'm little extending the discussion
It's okay. It's okay.
around, yeah,
Please.
around what you are discussing. I mean, if a study involves, let's say, 4 or 5 constructs, and items
Mhm.
are 4 or 5 items may be devoted to each of these constructs, or the number
Mhm.
will vary also, not necessarily only 4 or 5
Mhm.
equally. So in that case also, this makes a lot of sense in the sense that you call out those items which are for a particular relevant to a particular construct, and
Yes.
then convert into logarithm and check the sum. You take the sum and then check the normality of the database.
Yes, yes. You have to. So this is one method of summation, negate, minus, miss, whatever you want to do for all the items you can do from here.
The bottom line is, of course, you have to check normality of the data. Basically, that's what.
Yes.
That's
Yes.
right.
Yes.
Thank you.
There is one option where it is. Select all and see here. Yeah, this is log 10. Okay.
Yes.
If you want to convert the log, let's say I want to convert in this number as log. Okay.
Yes.
So I'll just name it log question 1. Log q1. Okay.
Mhm.
And you can see its logarithmic values have been created.
Right. That's right.
And let's see whether it's normally distributed or not.
Okay.
So it's a large sample size. So I'll go with one sample case,
Mhm.
normal. No, still it's not normally distributed.
We have to increase the sample size.
So sample size is large enough because now, sir, if you see my sample size,
Mhm.
for 23 questions, the responses are from 2,571
Oh,
responses.
that's huge. That's huge. Yes. Okay.
So this is not working. Then
Mm.
the next step is to bootstrap the model. Let's say if you are doing the mean comparison, okay,
Mhm.
your data is not normal, but you
Mm.
want to do this mean. So already I have told t-test, for t-test or any test, data should be normally distributed.
Right.
If it is not normally distributed, simply bootstrap.
Okay.
And what you can do, perform bootstrapping.
Mhm.
You can increase the number of samples from here.
Okay.
How bootstrap works, let me tell you. It creates actually, suppose if you have 200 samples, okay,
Okay.
and it's not coming normal, and you want increasing size or sample size also is not working, logarithmic is also not working. So
Okay.
when you bootstrap the model, what you do, you create mirror images. Let's say if you have put 1,000, so what it will do, it will take randomly, it will create 1,000 items, okay,
Mhm.
1,000 responses, which will be the mirror images of your actual responses.
Okay.
Okay. So if your norm, let's say this is your, I'm bad at drawing, normal distribution, right?
Okay.
Your data is now distributed, let's say, somewhat skewed.
Okay.
The moment you bootstrap the model, what will happen?
Mm.
It will elongate this curve. Means
All right. Okay.
it will create robust confidence interval. If
Okay.
this curve is elongated, then
Oh,
there is a high chance that the data will fall into this region
right.
under the bell curve.
Right. So that skewed part is
That,
knocked
that,
off.
that's what bootstrapping does actually.
So skewed part is knocked off from the database. I mean, the
Sorry?
top one, the skewed portion of,
It will get elongated actually.
yeah,
Confidence interval will be increased.
okay.
Okay. So
Right.
bootstrapping helps you when you want to perform a test which requires data to be normally distributed, but your data is not coming to be normally distributed by any means.
Mhm.
So bootstrapping should be practiced only at the final stage. First,
Okay.
try to increase the sample size,
Mhm.
take the logarithmic value,
Mhm.
or summated score also will work. If none of these are working, then bootstrap.
So what is the pitfall of using Bootstrap?
No
Because
pitfall. There is no
no,
pitfall, sir. There
okay,
is no
in the
pitfall.
sense, why?
Only thing is you need to explain why you have done bootstrap.
Okay.
There is no pitfall.
No, pitfall in the sense that you said this should be practiced as a last resort. I mean, this should be used as a last
This,
resort.
yeah, this should be used as a last resort because what you are doing, you are creating mirror images. Because the thumb rule says first you bring your data to the normality. If it is not normally distributed,
Then the
either
entire
by sample size or by logarithmic values or by any means, then only you should do this. There is no pitfall. This is the last method which
resort
should
of
be done.
creating normality
Yeah,
or achieving normality, right?
because here you are, what you are doing, you are not taking the actual data, you are taking the mirror image of the data, you are elongating your confidence interval curve.
Okay.
So that should be the last one. And
Right.
second thing I have found, if your reviewer is not expert of statistics, he won't understand what this bootstrapping is.
Okay. Yeah. Okay.
Again, they won't be able to comprehend what you want to say.
So that could be that would have different.
I'm sure there are many of you people have seen this method, this option in
Mm,
every test. It is there. Let's say if you are doing correlation in
mm,
every SPSS, every version you will find this bootstrap. But
mm.
I'm not sure how many of the trainers have
Notice.
told you about bootstrapping.
No, it was the first
Huh?
time that.
Because people tend to avoid this. It's very hard to interpret. However, it's not a means rocket science.
Mm,
Simple thing that bootstrapping does, it creates the random values of your data, right? If you
mm,
are saying 10,000, your
mm.
sample size is 200, it will create 10,000 mirror images of your data.
Okay.
And that what will happen, your data will tend to be normal. Somebody raised the hand.
Me, sir.
Yes, please.
Sir, is there any possibility? If there is a possibility, can you show an example where normality is not there, and then we went into logarithmic values and then summated values and then finally bootstrapping? Some
Sir,
example.
bootstrapping example we will cover during CFA, sir, for sure.
Done,
Migration
sir. Done,
modeling,
sir. Done, sir.
which because this data which I am working with does not actually violates any of the assumptions. It's purely clean data.
Okay, sir. Done, sir.
So we will come up with the data and tell you how to bootstrap.
Done, sir.
And of course, after this course, I'll be sending you a lot of ebooks, study materials, which will be of help to you.
Thank you, sir.
Because currently this data I'm working with is thoroughly cleaned and coded. So if there is no error, then means it won't lead to any result. Okay.
Yes, sir.
But definitely we will cover this for you.
Yes, sir.
Bootstrapping.
Yes, sir.
Okay. But yes, what is the basic behind bootstrapping? You should know that bootstrapping creates robust confidence intervals. Means your confidence interval curve, that is the bell shaped curve, will get elongated, and if it gets elongated, then the skewness will be decreased. And how it does? By creating mirror images of your existing data. Clear?
Yes,
Okay,
please.
should I proceed?
Yes, please.
Okay, enough on the sample size, we have discussed a lot. Okay, now first let's test for KMO. So go to dimension reduction factor, take all the questions here, and descriptives. We want KMO and Bartlett's test of sphericity. Continue. Okay. See, due to large sample size, my KMO value is coming to be very close to 1.930. The minimum cutoff is 0.5. So this KMO is okay. My Bartlett's test of sphericity is significant. So it's good to go for factor analysis. Is this point clear?
Yes, sir.
Why my KMO is very high? Minimum is 0.5. That you can achieve by 1:5 or 1:6. In my case, the item to sample ratio is approximately 1:110. 23 questions and 2500 responses. Okay, that's why. So this is met. This is significant, Bartlett. So it's good to go. Initially step, it will show you this commonality also, right? Here you can see that initially the commonality was 1%. After extraction, it is decreasing to 0.435. What does it show you? It tells you that the total variance is not explained only by the common variance, because this is the common variance among them. So what is remaining? 1 minus this value is the unique variance. If after extraction this would have been 1, then there is no unique variance. There is a common variance only. So what is it is telling you that if you will do the extraction, the commonality will be only 0.435, the common variance. Unique variance is the remaining 1 minus 4.435. So this table itself is suggesting me that the total variance is explained by a common variance plus a unique variance. Has it been after extraction also 1, 1, 1 in all cases? That means that there is only common variance and you should apply principal component. But it is telling me that common variance is only this much after extraction. So I have to apply exploratory factor analysis. Is this clear? This table itself will tell you. Am I clear on this?
Yes, sir.
Okay. Now let's go for, see, I can do all this at once, but I will do it step by step. Factor extraction. So here I have to choose, this is what people do wrong. This they click continue. They report EFA, but it's by default principal component. So we have to do EFA. There are many methods of dimension reduction. So for factor analysis, principal component and EFA. Since we have to do EFA, we will choose the method as principal axis factor. Then we will select scree plot, and the extraction should be based on eigenvalues because we don't know how many of them we have to do.
Excuse me, sir.
Iterations. Yes, please.
Sir, this 0.435 is 1 minus h square, or
No, no,
what
no,
is?
no, no. No, no. This is not 1 minus h square. This is the value of h square.
Okay,
Means this is the common variance.
okay,
So the unique variance will be 1 minus this value.
okay,
So this
okay,
is suggesting that, see, if this also has been 1, then what it suggests that h square is 1 in all the cases. Means there is only common variance.
yes,
This is showing that common variance is only 0.43, 43.5%. Then what
Yes,
is
sir.
remaining? The unique variance, 1 minus 0.435. This table itself is suggesting that the total variance is explained by a common variance plus a unique variance. If
Yes, sir.
all could have been 1, that means there is only common variance. Apply PCA. But this is suggesting that there is common variance only this to this much level. The remaining is the unique variance. So which one to apply? EFA,
Okay.
right?
Yes. So, sir, in real life, is it possible that this extraction came out to be 1?
Most of the cases, if you are taking similar questions, it will come out to be 1.
Okay.
See,
Okay.
if you are taking highly correlated questions, okay,
Yes, sir.
which are measuring only one dimension, it will come as 1.
Okay, sir.
And then apply principal component analysis.
Okay, sir.
Okay.
Thank you, sir.
Okay. For principal component analysis, the principal component method. For EFA, principal axis factoring. Okay. At this stage, we are doing extraction only. So scree plot, we don't know how much to extract. So we'll be doing on eigenvalues. The cutoff is eigenvalues greater than 1. That should be. Maximum iterations for convergence is 25. You can change it to any value up to 100. Since we have a very large sample size, so we will keep maximum iterations to 100. You can choose. Minimum is 25. You can choose 20, means 30, 40, 50 based on your sample size. We have a very large sample size, so we are taking 100 iterations. Right? Even we can achieve by 25, but on a safer side, or due to a large sample size, we will keep the maximum iteration to 100. Is that clear?
Sir, please, will you explain this maximum iteration for convergence again?
See, sir, by default, this value is 25. Means how many times it should iterate your data for convergence. This software. It is
Okay.
25 by default. If
Okay, sir.
you have a very large sample size, then you can increase this value. Since we have a very large sample size, 2500 is not a small, it's a very huge sample size.
Yes,
So
sir.
to be on a safer side, we are putting maximum so that it can check maximum iterations for 2300 samples for
Yes, sir.
convergence.
Got
So
it, sir.
that's we are putting it to the maximum value, which is 100. Okay.
Yes, sir.
If you put it 1000, then it will again take a lot of time. So 100 is on a safer side. 25 should be the minimum by default. Okay. Am I clear
Yes,
on
sir.
this? So just to be on a safer side, I am taking 100 due to large sample size. Continue. Okay. So at this step, I am not doing rotation. Now see, due to this iteration, it is taking time. So maximum you can put 100. If you have a large sample size, otherwise 25, 30, 40, 50 is okay. Now see, till what factor eigenvalues are greater than 1?
Sir, it is
Factors, sir.
Till
4.
fourth, till
Yes.
fourth.
Yes, sir. Fourth,
Yes, sir.
sir.
So it is suggesting me to take 4 factors. Okay.
Yes, sir.
Okay. Now let's look at the scree plot. If you see, there is a sudden influx happening at the second point,
Yes, sir.
Yes, sir.
and also there is an influx happening at the fourth point also. Can you see this?
Yes, sir.
So scree plot is suggesting me that either you can take 2 factors or you can take 4 factors, because after that all factors are in the decreasing order. So this scree plot tells you the number of, see, first thing you should see this, that till 4 eigenvalues are greater than 1. So we can take 4 factors. Then scree plot is suggesting 4 factors, and even you can take 2 factors also. Because sudden influx is happening at the second point, and if you see after fourth point, it improved at the fourth point, and then again there is an influx, and this influx goes on, means decreasing. So till fourth, either 2 factors or 4 factors. Is that clear?
Yes, sir.
Now, Let's see, if we take two factors, how much variance is explained? 34%. But if we take four factors, how much variance is explained? 40%. So, which one we should take? Two factors or four factors?
Two, sir.
4 factors.
4 factors, sir.
Sir, anyways, if you take two, only you will get 34% of variance explained. The model improves by 6% if you take four factors. That's why scree plot should be taken into account to see how at how many points influx is happening. So it is saying you can take either two or four. But if there is no improvement in the, if I'm adding more, taking more factors and there is no much improvement in the variance explained, then I can restrict it to two. But since I'm seeing that approximately 6% improvement is there, given the large sample size, 6% is very high. So I will take four factors. Am I clear on this?
Yes, sir.
So this table will tell and this scree plot will also tell. But scree plot will be more clear on the influx point. This is nothing but the plotting of this only. So you can take two factors, you can take four factors. I'm seeing that if I take four factors, the model improves from 34% to 40%. So I'll take four factors. Otherwise, I can do away with two also. All my items will load on two also. But if better it is, then why not to take the four factors? Okay. So now I will go to dimension reduction, factor, extraction, principal axis factoring. Now I will take fixed number of factors, 4, continue. Then I will move on to rotation. So we have chosen EFA. So which method we should choose for rotation? Direct oblique mean or orthogonal or oblique?
Varimax, like orthogonal.
Orthogonal. And Varimax, you can take Varimax or Promax. Varimax is widely used. So let's see. And there also we have given 100 iterations. So it should be 100 only. It should not change. So if you have given in extraction 100, then in rotation also 100. And scores. So save as, so standardized scores, regression method, continue. In options, nothing to do. Yes, this one, suppress small coefficients. Normally, we take coefficients which are explaining 50% of the variance. So all those which explains 40% or less than that, we remove them. So here we will keep 0.4. That is the thumb rule that normally suppress a small coefficient which is having value below 4 because they are not desirable. So those items will be which will be having coefficient less than 0.4 or less than that will be removed because 50% of the variance is the minimum requirement. Continue. Okay. All things will happen again. Now, if you see the factor matrix, this is till the rotation. You see that nothing is loading on fourth. First thing. Question number 6 is loading on 1 also and third also. Question number 8 means multicollinearity problem is there. So it's always better to rotate, and now you see the rotation matrix. It gives you better interpretability. That's why we go for rotation. Now let's see how the items are loading. First, factor 1. Which are the questions that are loading on factor 1?
Sir, question number 1, 3,
1.
4, 5.
3 is not loading. Please remember variance and the values cannot be negative.
Okay,
We will discard this.
okay, sir.
Okay. I have already given you the thumb rule for eigenvalues. Okay.
Yes, sir.
So question 1, question 4, question
5,
5,
12,
12,
question 12,
16,
Question 16.
20,
Question 20.
21,
Question
21,
factor 2.
6,
Let me put all this at once.
45 minutes each into 10 hours and 15 hours.
Factor 2, question number 6.
7,
And you can see that there is no such case that one item is loading on many factors. So that's the beauty of rotation, that it gives you better interpretability. Question 6.
question 7,
And if one item is after rotation also loading on more than one factor, then there is a problem of multicollinearity. Please check your variables. Question number 13.
14,
Question number 14.
18,
Question number 18. Coming to factor 3. Question number 8.
11,
Question number 11.
17,
Question number 17. Factor 4.
2,
Question number 2.
9,
Question 9.
22.
Question 20. So we started with 23 questions. Let's see how we have got. How much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Out of 23, 18 are of our use. Rest 5 we have discarded. Which one we have discarded? Question number 3, because it has a negative value. Then question number 10 is loading nowhere. Discarded. Question number 15, loading nowhere, discarded.
20,
Question number 19, loading nowhere, discarded.
23.
Question number 23, loading nowhere, discarded. So these 5 questions have been discarded. Now let's see question number 1, 4, 5, 12. Let me open the questionnaire.
Sir, why we didn't choose question number 3, sir?
Due to the negative value. Eigenvalues cannot be negative, right? The
Okay,
coefficient cannot be negative.
Okay, that was not visible to me. Okay, right.
Yeah, okay. Now let's see the questions. So question number 1, statistics makes me cry. Question number 4, I dream that Pearson is attacking me with correlation coefficients. Question number 5, I don't understand statistics. Question number 12, I did. People try to tell that SPSS makes statistics easier, but it doesn't. Question number 16, I weep openly at the mention of central tendency. Question number 20, I can't sleep for thought of eigenvectors. Question number 21, I wake up under my duvet thinking that I'm trapped under a normal distribution. All these are having something common. What is that commonality? Isn't it?
Statistics.
Isn't it? Fear of statistics. So factor 1 is fear of statistics. Factor 2. Question number 6. I have little experience of computers. All computers hate me. I worry that I will cause irreparable damage because of my incompetence with computers. 14. Computers have minds of their own. Question number 18. SPSS always crashes when I try to use it. Fear of computer use. Number 3. Question 8. I had never been good at mathematics. Question 11. I did badly at mathematics at the school. Question 17. I slip into a coma whenever I see an equation. Fear of. Then question number 2. Friends will think I'm stupid for not being able to cope with SPSS. Question number 9. My friends are better at statistics than me. Question number 22. My friends are better at SPSS than I am. Fear of
Here.
peer evaluation. So these are our 4 factors explained by these. Okay.
Yes, sir.
And if you see at the last, we have saved this course. We have got the standardized scores of these factors also. Now our structure will be like this. 4 factors we have got. So now SPSS anxiety is explained by fear of statistics, fear of computer use, fear of mathematics, and fear of peer evaluation. And these fear of statistics is explained by these questions, fear of computer use is explained by these questions. So finally, when we will model the relationship for CFA and SEM, for the first one, we will take these questions, set of questions, for the second one like this. So now our structure is clear. This is about EFA. Same method you will apply, but only thing that you will choose here is method will remain same, everything will remain same. If you have to do principal component analysis, then in extraction you will choose principal component. That's it. Nothing, no difference between EFA and PCA in SPSS. Only the method you have to choose. But initially, when you will create descriptives, then it can help you to understand whether you should go for PCA or EFA. While checking this, okay, this we have done. One more thing we check is validity. So,
Excuse me, sir.
yes, please.
Sir, but when we apply this principal component factor, like factor analysis method, then we will get only one factor, or we will get more than one factor in that case. I think
No,
we
you
will
got
get one
four.
factor na?
No, you got 4 factors here, na?
For PCA also, when we use PCA.
See, for PCA also you will get depending how many factors. Because if everything is loading on one factor, then there is no use of factor extraction, na?
Yes, sir.
So there also you will get more than one.
Okay, yes, sir.
But what will happen? They will have something, some correlation among them. When now further, if you want to check what is the relationship between these constructs, then you have to perform CFA.
Okay, sir.
Okay, CFA will tell you how these are related. So if it's a principal component analysis, CFA will tell you that all are highly correlated with each other.
Okay, sir.
Okay. You will
Yes.
get, means you can get 2, 3, means depending on the data, okay, you will get
Yes,
it.
sir.
Otherwise, see, all will load only on one principal component or factor only when eigenvalues are 0. And that is a bad fit.
Yes, sir.
Then what is the point in doing extraction and rotation? For doing extraction, why we are doing extraction and rotation? To know that our items are converging into how many factors or
Yes,
principal
sir.
components. So if all are converging on one factor or principal component, then there is no use. Now it will become a simple structure.
Yes, sir.
So even see, there will be high commonality between all H square will be 1 in principal component analysis, but they will load on different factors. You will get
Yes.
different factor there. And further do CFA. Okay.
Okay, sir.
My this data is for EFA, so I have told you. And why I have taken EFA, because people have a very wrong notion about EFA. Mostly they do PCA by default and then report it as EFA, and then
Yes, sir.
then they get problem in SAM. Or see, this software is nothing but a piece of code. You enter some data, it will give you some data, but that data should make sense. So don't feel happy if you have done something wrong. You are unawarely you have done principal component analysis. Even if you do structural equation modeling or CFA, it will give you some structure. But whether that structure makes sense or not, that the point in question. Are you able to justify it or not? So that's why you should be very cautious at the initial stage whether you should do PC or EFA. So here, just to tell you about that, EFA method is based on principal axis factoring. I have chosen this data to tell you on EFA. You can do PC also, and PC you can do only by choosing the method of rotation as principal component. That's why I have taken up this to tell you about the variance partition and all these things. Okay.
Yes, sir.
Now, second thing for reliability, I hope you all know. So this is actually the pre-testing of the questionnaire. So this EFA you can do at the pre-testing stage also, and also you can do after you have collected the data. Anyways, because EFA, if you are doing at pre-testing stage factor analysis, it will help you to rearrange your questionnaire, because now your questionnaire will be containing, let's say, heading will be fear of statistics, and all the question of fear statistics will be at one place. This will help you actually the participants to concentrate on the filling the response, because first question is about statistics, then suddenly you are talking about peer evaluation, then suddenly you are talking about mathematics. They might actually get disoriented, or they might lose their concentration, and they can randomly just fill up your questionnaire. So it's always a better idea that you do this principal component or EFA after collecting some data, reorganize your this questionnaire, and then distribute it to the participants. That is a better approach. Are you getting my point? So that all
Yes.
questions measuring one construct should be at one place, so that respondent could be able to relate and fill it properly. Because nowadays the greater problem is getting the questionnaire filled. And please, my advice, it takes a lot of pain and time, I do understand. Please don't float your questionnaire over social media. Don't let any Tom, Dick, Harry fill your questionnaire. It should be correct respondents.
Yes, sir.
Okay.
So the same question I want to ask you, that please, if you can give some suggestions regarding how we should like collect the data from like if our sample is from HR professionals, then how should we approach companies so that they can allow us to take the data from their employees?
There is no standard method. It's all trial and error method. It could be that in one go you develop a good relation with the HR manager of that company, and he will help you out by
Okay,
chance,
sir.
right? But anyhow, please don't float it on social media. Don't ask it means XYZ person to fill your questionnaire. Please, your respondent should be true respondent. Otherwise, you will get numbers, you will get some tables, some values, but that won't be of any use to you. And right now, there, Kaggle, I have told you already, lot of data is there only. You need not to collect the data through questionnaire itself. Lot of data is there. Already cleaned, coded by the community of data scientists. Even I have contributed many data. So what happens to me whenever I get a questionnaire on my WhatsApp from somebody to fill it? Guess what I do? I go through the questionnaire, and rather than filling it, I just respond by pointing out where is the error in their questionnaire to make their questionnaire correct. So ideally, you can see if somebody sends me the question, and many people have appreciated it, that okay, at least we found somebody who has corrected our questionnaire. And then I suggest that don't fill it like that. Otherwise, there will be serious problem with the results. Okay, now
So, sir,
yes.
one last question, that Sir, in Kaggle.com, how we can find data set related to business or management? Like, I don't find the data set related to business and management over there.
What do you want to find? Please tell me.
Sir, any data set related to business and management field.
Just tell me, na, means what data you want.
Sir, like for example, like emotional intelligence or like work-life balance.
Can you see this data containing all these values? Okay,
Yes, sir.
this is the huge data. Okay, containing all these values. Can't you make it out? Their work-life balance. Can you get this? Are you seeing this variable? Yes, I don't know who asked this question. Can you see this variable work-life balance over there?
Yes, sir.
Ah, relation satisfaction, performance rating means you can write at least 10 papers from this data itself. What are the benefits given them to them? Why they quit the company? You can do a lot of things from here. But still, if you want to collect first-hand data, see
Yes.
see there is no sure shot method. You have to be means it's an art and science both. There should be some motivation for people to fill your questionnaire. But if you send it over a social media, your friends for your friends to fill it, it doesn't make sense.
Yes, sir.
Get what
Definitely.
I mean to say? It takes a lot of pain, but try to get the correct respondents. Okay.
Yes, sir.
And
Sir,
of
thank you so
course,
much.
this is cleaned and coded data. If you search, there are tons of data on Kaggle. And if you are not getting data, please get to me. I'll send you the data sets. Okay.
Sure, sir. Sir, thank you so
Thank you.
much.
Thank you.
Okay. So now the next thing I need to cover reliability. I hope you all know, but just I'll go through it. So after doing this dimension reduction, the next thing is that we should do reliability also. So scale reliability. See, there are many methods, uh, split half, Beckman parallel, strict parallel, Cronbach alpha. So just in short, split half method should be used when you have used reverse coding in your questionnaire. Okay. Few questions you have coded from 1 to 5, few questions you have coded from 5 to 1. If reverse coding means you have divided your question into two halves. The first statement is the positive, another statement is just negative. With reverse coding, then don't use Cronbach alpha. I hope you understand what I mean by this reverse coding in the questionnaire.
Yes, sir.
Yes,
So
sir.
let's say your first question is, I feel happy at workplace, strongly disagree to strongly agree, 1 to 5. Second question is, I feel trapped at my workplace. Similar question, but
Yes, sir.
reverse coding. Then, which is a negative statement. Then, in that case, don't use alpha. Use split half method. Okay.
Okay, sir.
when you have given the same questionnaire to two different set of respondents. Okay,
Yes, sir.
let's say you are trying to measure the attitude of males and females. For males, you have made a separate questionnaire. For females, you have made a separate questionnaire, but questions are not different, they are similar. I'm not saying same, similar. Okay, in that case, use the parallel method or strict parallel method. Clear?
Yes, sir.
Okay. However, generally we make questionnaire as I have shown you. So one method is alpha, but also choose these three statistics: item, scale, scale if item deleted. What it will give you, let me tell you. First, select all this. Select these three: item, scale. Means you want for item the scale, and scale if item deleted. Continue. Okay. So, because if you don't select all these three, you will get only this reliability statistics. So, zero point 0.7 is the cutoff. We have got 0.754. Suppose if it is less than 0.754, or much less than 0.7, then I need to see that why it is coming to be low. See, if it is less than 0.7, but greater than 0.5, or up to or zero point 0.5 or greater than that, then revise your questionnaire. Recode your items or do choose a correct scale. If it is below zero point 0.3, please remove that item. But how you will come to know which item is creating problem? This, because I have selected one more thing, scale if item deleted. So if I delete question 1, my reliability will go to 0.735. It will decrease. So I have to retain this. If I delete question number 2, reliability will go to 0.6768. There is no much difference between what I am getting and what I am getting after deleting here. So if you see all the cases, there is no much improvement in reliability that I can do. And already my data is reliable, so why to look at this table? If it is not reliable, then look that which of the item is creating problem, delete that item. If it suggests that after deleting, it will go to 0.7 or beyond, delete that item. So that this table will tell you. So don't only restrict yourself to calculating this Cronbach alpha. Select those three statistics also. So it will give you individual Cronbach alpha also, and also if an item is deleted, how it will impact the Cronbach alpha. If your Cronbach alpha is less than 0.7, of course you should look at this table that which item is creating this problem. If this table suggests that none of the items is creating problem, questionnaire itself is a problem, consider revising the questionnaire. Clear?
Yes, sir.
Yes, sir.
This
Sir,
will help.
like how many
Yeah.
questions we can delete? For example, if it requires us to like remove 8 questions, then should we go with this, or we should reconsider the questionnaire or redesign the questionnaire?
First step is to redesign. Okay. If
Okay,
you
sir.
feel that that question is important for you, then consider redesigning it. If it's not important at all, straight away delete it.
Okay, sir.
It's up to you. Okay. If it is suggesting, this table will suggest that after deleting, what will be the impact? If simply deleting one or two questions is increasing your Cronbach alpha, do that. Why you? Because if you will reword the questionnaire, refresh, again you have to go and take the responses. But if
Exactly.
there is a lot of problem, then of course you have to work on your questionnaire. That's why I'm saying that please make your questionnaire at the initial stage very correct so that you don't face all these problems. And never be happy when you get the reliability Cronbach alpha value of 0.9 and above, please. It is a multicollinearity problem. 0.7 to 0.9 is okay. First thing. Second thing is that don't use Cronbach alpha in all methods. I have already told you, if you have given the same questionnaire to two different set of people, containing similar questions, use parallel or strict parallel method. If your questionnaire contains reverse coded items, please use split half method. So these are the methods. Other statistics will remain the same. This is reliability. Now coming to the validity. So validity is also sorry, concept validity. Its validity. Main, there are two modes, but they are not required. Basically, they are actually, we call them as concurrent validity and predictive validity. No, it's not coming up. Predictive validity. These three are important. Concept validity is when you want to know, because validity is itself the truthfulness in measurement. Means your instrument, survey instrument is measuring the same concept which you want to measure. All your questions are measuring that. To know that, we apply concept validity from expert. If you see the papers, they will mention that they have get it reviewed from the expert. This is the first step. They will tell. Let's say if you are doing some analysis on work-life balance, then get to the people who have already done research on the work-life balance. Get to HR professional people. Means you should have at least two reviews from the expert from academia and expert from this industry. So they will tell you whether the questions are correct or not. Then face validity is established. These are qualitative methods. When respondents, this is done in pre-testing stage. Respondents comprehend the questions the same way as you want. Means what you want them to understand, they are actually understanding the same thing. Otherwise, there will be a mismatch. They won't be able to answer you properly. So these are the qualitative methods. This is a quantitative method. It consists of two validities: convergent validity and discriminant validity. So both these validities should be there. This could be done in CFA also and EFA also. In CFA, we take the average variance extracted. If uh, if average variance extracted value is greater than 0.5, then convergent validity is there. And if the square root of each of the coefficient is greater than the average variance extracted, then we call it that the discriminant validity is there. Both these validities should be there. The basic idea behind this is all items measuring a construct should be highly correlated. Items measuring one construct should be weakly correlated with the items measuring another construct. What does it mean for you? See, all those questions measuring fear of statistics should have a high correlation among themselves. That is construct validity. Similarly, all questions of fear of computer use, all questions of fear of mathematics, all questions of fear of peer evaluation should have high correlation among themselves. But questions measuring fear of statistics, when all these questions which are measuring one construct are highly correlated with each other, we call it as convergent validity. When all items of fear of statistics are weakly correlated with items of fear of computer use, fear of mathematics, and fear of peer evaluation, Similarly, fear of computer use items are weakly correlated with items of fear of statistics, fear of mathematics, and fear of peer evaluation. We call it as a discriminant validity. For construct validity, both convergent and discriminant validity should be there. You can do in CFA also, and in EFA, let me tell you, when you will do this dimension reduction factor, in descriptives, what you can do, you can, under correlation matrix, see coefficients. After doing this EFA, it will give you a correlation matrix where it has gone. Okay, this is the correlation matrix. Now you have already identified that what are the constructs of factor 1. So see that those questions should be weakly correlated with negative positive value doesn't make sense here, only the magnitude. They should be weakly correlated with the items measuring other constructs and strongly correlated with items measuring that particular construct. Little bit of deviation could be there. That's not a, 2 or 3 items might not be converged or diverged. That is not a major problem. Okay, so in EFA you can do by correlation matrix. In CFA you can do by, when you will do CFA you will see the model fit indices and average statistics, which is average variance extracted and square root. You can do by that also. We will explain that in CFA part. Okay. So that was from my side for today. Any questions? I'm open to.
No, sir. Let us